Hey, so we're gonna be talking about similar triangles over here today. The SAT loves similar triangles. It's like they're, one of their favorite little pet concepts. And the digital SAT is like that too. They continue its love affair with similar triangles. So it's really important not only that we grasp the basic concepts of similar triangles, but also I want to show you this important similar triangle shortcut later on in the video that's going to really help speed up the process with these similar triangles. So you have your more time and energy to spend on other crazy questions they care about on this test. So real basic, we got a couple triangles here. Triangle ABC, triangle DEF, and if they're similar, it means their corresponding angles are exactly the same. So like angle A over here corresponds to angle D. These two angles are the exact same measure. Same with angle B and angle E. I labeled them both right angles, so we know they're the same, but whatever. Angle C and angle F are also exactly equivalent measures. So the corresponding angles are all the same. And the corresponding side lengths are proportional. Now, what does that mean? Well, it's kind of like saying that one triangle is like a scaled up or down version of the other triangle. So maybe all the corresponding side lengths of one triangle are twice the length of the other triangle, or triple the length of the other triangle, or 1.5 times the length of the other triangle, or 90% of the length of the other triangle. So we got that going on. They're proportional side lengths. So that's what similar triangles are. That's the basics there. Now, one thing they'll do to ask about them, first of all, they often won't draw them out like I did here. They'll just tell you about them. They'll just say triangle ABC, triangle DEF, triangle JMK. Like they'll just tell you about them. And the reason they're not drawing them out for you is because it makes it harder to keep track of which angles are corresponded to each other. Like if we look at these two triangles here, it's clear that angle A and angle D go together, right? Because they're like in the same position in each triangle. But if I just tell you combinations of three letters, A, B, C, D, E, F, it's going to be harder for you to keep track of that, especially in the context of a timed test that has some relative stakes for your life. So what is the solution if they don't draw the triangles out? If they don't draw the triangles out, then you must draw the triangles out. I hope I don't need to say that too much here. You're already doing that, right? Like in a geometry question, if they just tell you about a triangle and they don't show it to you, you're already drawing it out, right? Aren't you? You need to have a visual going. For the same reason that for me to teach you this, I use the visual because it's more helpful. It helps me explain it and show you what I'm talking about. For the exact same reason, you need the visual when you're doing the problems on your own. So that's a very important habit for you to just have. Draw stuff out if there's something to be drawn. Okay, so the way they'll talk about this is they'll tell you about the triangles. They will tell you that they're similar. They might give you some side lengths like this. And they'll ask you something like this. Cosine of angle F. This is one of the ways they like to test SOHCAHTOA trig kind of stuff. Now, you'll know what cosine is, right? SOHCAHTOA is adjacent over hypotenuse. So we look at angle F over here. The adjacent side, we don't know. The hypotenuse we see is 169. And here's what the SAT wants you to do. They want you to look at this and say, oh, well, I have a missing side over here, but I know these two triangles are similar, so I can set up a proportion to find that missing side, right? So like, let's call this missing side X, and let's set up this proportion here. So the corresponding side to this unknown side is 5, so I'll just say 5 over X equals hypotenuse over hypotenuse, 13 over 169. And then I'll cross multiply and solve for X, and then I'll have my missing side over here. Or we could also say, set up the proportion this way, like, oh, well, since they're similar triangles, hypotenuse over this side is going to equal hypotenuse over this side. So I could also say 13 over 5 equals 169 over x. Same thing, it's going to get us to the same answer, and we'll have the missing side, and then we'll do adjacent over hypotenuse, and we'll have the answer. That's what the SAT wants you to do. That's not what we're going to do. They want you to do it because that's going to take longer. And some traps on the SAT are designed to lead you to a specific trap answer, whereas other traps are just designed to waste your time. They're trying to lure you into doing something like this, just to add another minute or so to your process in this question, because the more time we take for this, the less time we have for other questions. And also, the more steps we introduce to our process here, the more opportunities we have to make little silly mistakes, right? Little calculation errors, whatever. So no, we're not going to do it that way. We're going to be a little more strategic about this. Part of what it means to have similar triangles is that the relationships between the sides are the same. Like I was just saying, hypotenuse over this side here equals hypotenuse over this side here. That's what trig stuff is. The sine of an angle is a relationship between two of the sides. The cosine is a relationship between two of the sides. Tangent, secant, cosecant, that stuff, but that stuff's not on the SAT. Those other ones. Don't worry about those. All the corresponding trig stuff is the same. That's always going to be the case with similar triangles. So they ask us about cosine of angle F. Well, all we have to do is see which angle is angle F's cousin over here on this triangle. It's angle C, right? So they say cosine of angle F, that's going to be the same thing as cosine of angle C. So we just need to use this triangle here. This whole triangle here is pointless. Cosine of angle C, adjacent side is 5. Hypotenuse is 13. 5 over 13. That's our answer. We're done. This would have given us, it would have given us something over 169 that would have reduced to 5 over 13. So don't be all saying, oh, well, it's a different number. It would have reduced to the same thing. That's how similar triangles work, okay? If you got a request for another concept you'd like me to talk about, go ahead and leave a comment. I'm Coach Dalton. This is Mathicists. I drop these SAT tip videos every day, so definitely subscribe if you find this valuable. CoachDaltonFoster at gmail.com. Apply to work with me. Check out my subreddit, Mathicists. I'll see you in the next one, okay?